Hi. So I'm going to present a peer review method and app that I developed. The full paper is currently under review. I did present it in a couple of workshops, but it wasn't videoed. So this is why I'm now creating this informal presentation, just so that if you're interested, you can have a general idea about what this is about, and you can always feel free to contact me for more details. So we tend to talk about data-driven project versus model-driven project. This is a student-driven project. I teach an undergrad data analytics course. These are some of my students. At the end of the course, the students need to present a project in class. And in order to keep the students attentive and motivated during the presentation, the grade that each project receives, part of the grade I give, but part of the grade the students give. So this is a peer review thing. Now, students tend to be very generous in their grades. So they see a project presented in class and they will give it a 10. And then they see another project presented in class and they give it also a 10. And bear in mind that these projects are their friends presenting. So of course, they are very, very generous. Now, if I ask these students, which project do you prefer or which project do you think is better, they will know to say, but this isn't reflected in the scores. So they have all of this information that's in their head, but I didn't manage to elicit it. So this is a preference elicitation problem, which means there is a tension between the limited information available as it was reported by the voters or users, or in this case, students, and the goal. The goal is to present a quality outcome and not just give all of the projects a 10 because the students gave a 10 to all of the projects. So I was, when I first started teaching this course and using this method, I didn't know exactly what to do about it. One option is to ask students to rank projects. And this is problematic because students are able to say what is their most favorite project and maybe what is a project that they like after the most favorite in the second place. And usually they're also able to say what is the worst project that was presented and maybe the second to worst project. But the problem is all of the middle projects. So if you sit in a session and see 10 projects, it's easier to put them, to rank the highest ones, to rank the lowest ones. And the problem is the middle. Which project should I put in the 5th place and which project should I put in the 6th place? This is something that creates a cognitive overload. And this is not something that is unique to my students. This is based on previous research. Research says that people cannot rank more than 5 to 7 items. And research also says that people often don't even know their own preferences, okay? So they need to put a lot of thought into it, and still they will have a problem if I ask them to rank more than 5 to 7 projects or items. So one of the solutions that are available is to ask people or students to compare pairs of projects. So if I ask students, do you prefer this project or that project, they will know to tell me the answer. The problem is that even if I have only 4 projects, I will need to create 6 pairwise comparisons. If I have 5 projects, 10 pairwise comparisons, 6 projects, 15 pairwise comparisons. So here it's not a cognitive overload because these questions, people find them easy to answer, but we have a communication overload. I mean, people will not sit and communicate with me for so long and answer so many questions. Which brings us to the easiest solution, which is to ask people to give a grade or a score to a project. And this is a solution that is often used. Booking.com uses this solution. TripAdvisor uses this. Olympic Judges uses this. Amazon uses this. Mostly when you're online, you will be asked to provide a score. Teachers use it because this is so easy. So this is what is often used, but this is not without problems. I told you the students are friends of each other, and it's very easy to manipulate scores. So if my best friend presented the Unicorn Startups project, I can give a 10 to this project, but just to make sure that my friend is ranked at the top of the class, I can also give a 0 to the rest of the projects. So this is a problematic. One workaround for this is to look at the median and not at the score. So if we look at the median of the project, we are not so manipulable, but we have a lot of ties. Again, because most of the students give sort of the same scores to all of the projects. And I'm going to present you some real data. This is the students that had to rate. This is about 30 students who had to give scores to 10 projects. So these are the projects numbered 1 to 10. And this is the scores the students gave, and this is the median score. So you can see, for example, that the median score of project number 1 was excellent, and that actually all the scores of project number 1 were either very good or excellent. No student gave this project a score that is below very good. And you can see that out of 10 projects, I have a median score of excellent for 6 projects and very good for 4 projects. So this is problematic because it doesn't give me a lot of information. So if I sum up the preference elicitation problem, it's a problem to rank items because I get a cognitive overload. It's difficult to do. It's a problem to compare items because then I have a communication overload. That's just a lot of communication I need to get going with a student, and people will probably give up or start answering randomly sometime during the process. And I can ask people to rate items, but then if I use the average, it's manipulable. And if I use the median, so I have made many ties using the median. So after this introduction, we come to the main part of the talk. This talk is about a method I invented to deal with this problem. The method is called rating to ranking, or R2R for short, and it consists of 2 models. A preference elicitation model, which is in charge of eliciting ratings and performing pairwise comparisons as necessary. And in a minute, I will explain what it means as necessary. And it also consists of a preference aggregation model, which computes a median and then uses one instance of R2R. There's 2 possibilities in order to break ties. So how does the preference elicitation work? The pseudocode is in the paper, but let's not dive into that. Let's look at a simple example. Let's say a student gives a score of 5 to one project and then a score a 4 to another project. And then when the third project is presented, the student again gives this score a grade of 5. So now we have two projects with the same score, a score of 5. And this is when the system issues a pairwise comparison between these projects. So now the student has to answer a simple question: which project do you prefer, this project or the other project? In the end of this process, we get for each user a ranked list of all of them in projects and all of the scores. So this is the preference elicitation. For preference aggregation, we first compute the median, and then we need to use either R2RB or R2RC to break the ties. R2RB is based on the well-known Bovda voting rule, and the full, it's in the paper, but now I'm going to just present it in layman's terms. The full definition is in the paper. So the idea is that we compare every 2 items. And item I receives a point for every user that prefers item I over item J. And item J receives a point for every user that prefers item J over item I. And we sum the points of each item, and we order the items by their points. This was invented by Bourda in the 18th century. The other method, R2RC, is based on the Copeland alpha voting rule. And this means that we again compares every 2 items. And if more users prefer item I to item J, then item I receives 1 point. In Bourda, the points were all the number of users who preferred item I to item J. Here, if we have more users preferring item I to item J, so item I receives a point, and vice versa. If more users prefer J to I, so J receives a point. And if the items are tied, they both receive alpha points, and alpha can be a number between 0 and 1. I will jump ahead and tell you now that I tried a few different alphas, and I ended up working with alpha of a third, but you can set alpha to be whatever you want. The most common option is to set alpha to a half. And then you sum the points of each item, and you order the items by their points. Okay, so just to illustrate this, say we have 5 items that have the same median, okay? So this is not the scores given by a user. This is the median of all the scores of all the users. And now we need to use either R2R or R2RC to order these items. And then we look at the next bucket of items. This is all the items that have a median of 4. And again, only for these items, only for the items that have a median of 4, we use either R2RB or R2RC to rank them. We do the same if we have a bucket of items with a grade of 3 or 2 or 1. We do the same for all of these, and then in the end, we get a ranked list of the items. So since I have the users, I mean, I have students and I teach this class every semester, why not issue a user study? So I implemented a system in Python, and the system works like this. In the first step, the system is initialized. The admin enters all of the projects that are going to be presented in class, the names of all of the projects, and the students register to the system and they log into the system. Step 2 happens online in class. Students sit in a session, a project is presented, and after the project is presented, the students need to evaluate the project, okay? So they need to give it a score. Now, I didn't say this earlier, but I followed Balinsky and Lalaki's suggestion from their majority voting paper, and instead of asking students to provide a score on a scale, say of 1 to 10 or 1 to 100 or 1 to 5, I used a grading language. Why did I use a grading language? Because when I say 5, or when I say 4, maybe I mean a 5, and when someone else says 4, maybe he means a 3. I mean, there is bias in these things, but usually when I say excellent and someone else says excellent, we both mean excellent. So the idea of a grading language instead of grades is to eliminate some of the bias that is connected to grades and to the voters' personality. So the students needed to give each project a score, a grade using this grading language. It could be excellent, very good, good, fair, or poor. I could have put more grades in here, but this just complicates things, because again, then there's this cognitive overload. Is this project outstanding, or is this excellent? And what is the difference between outstanding and excellent? And I wanted to keep it simple. Bear in mind that this is happening in class. So excellent translates to a 5. So let's say that the student gave a project 5. What happens next is that the system checks if the student has already given the same grade of excellent or 5 to another project during this class session. If the student has never given a grade of 5, or maybe this is the first project presented, nothing happens, and the student just waits for the next presentation to begin. But if the same grade has been given before, the student will see a pop-up question with a pairwise comparison query, something like, oh, you gave this project and this project the same grade. Which project do you think is better? Don't grade them again, just tell us which project you think is better. So this is just an additional question. And once the student answers that, the student waits for the next project presentation as well. So this happens online. The students, the system was implemented as a mobile mobile application, not something that they need to download, just something, you know, they had a link and they logged on and they used their mobiles to do it, and it was really, really quick. So once students finished their presentation, by the time they were wrapping up and getting away from the board, and new students were coming on stage, this is the time the students were doing this evaluation. In the end, what we receive is an output ranked rating set. So we have all of the projects for each student, and for each student, we know what is a scores they gave each project, and we also know the ranking of all of the projects. So this is an example. If we have 9 projects in a session, this is an example output, okay? After that, when I have all of these ranked rating sets, I can compute offline. I can compute the rank aggregation and produce a final list. Okay, so just to show you some screenshots from the system, this is the main screen of the system, and this is what the students see when they log on. These are the teams, and blue button means that the student hasn't evaluated this team yet. A gray button means the student has already given evaluation. So let's say the team the student wants to evaluate is this team that did project about the Eurovision data. So the student clicks this, and then he receives this screen, and he or she can give an overall evaluation. Outstanding, very good, good, fair, or needs improvement. And then they can also insert feedback. The feedback part is not mandatory, but some students like to insert feedback, and I read it, so why not? I mean, I already have this online thing going on. And in case that, as I said, the same score was given to 2 projects, so we have this pop-up question of you gave Eurovision data and also the project about transportation in Jerusalem, the same evaluation, which do you think is better? And the students need to answer that. So this system, I've used it already in 2 terms, and I had 3 sessions in each term. So I had a total of 6 sessions. Of course, I removed all of the IDs and the project identification numbers and even the session dates and names, and I'm just naming the sessions A to F. I have, this is a number of students I had in each session and the number of projects in each session. And here you can see the median grade. So this is something that I already showed you, that in session A, 27 students, I had a median grade of excellent for 6 projects and a median grade of very good for 4 projects. And I didn't have any median grade. No project received, none of the projects out of 10 projects, no project received a median grade of good. So you can see that students tend to be in all of the sessions, students tend to be very, very generous. This is the least generous session and still it is very generous. This is just so you can like see a view of how this looks. This is a median in session A, B, C, D, E, and F. So this is the data I collected and is the data that I used. Of course, in order to collect the data, I received the approval of the ethics committee of my university, of Yale University. And I did have to remove a few students that weren't compliant, that either didn't fill all of the didn't answer all of the questions, didn't fill all of the data in their session, or I saw some weird stuff going on, like they filled all of the data at the same time, and then I knew that they weren't filling after every session. This is just minor details. It's in the paper exactly who and what I removed. So evaluation. First, I wanted to sort of look at the data and have a feel of do I have a order bias, and order bias, it can be of 2 kinds. There can be a primacy bias or a recency bias. So I was really concerned about that because the order of projects is random, but maybe it affects the final score. So for example, if let's say that the projects are presented first project 1 called C1, then C2, then C3, then C4, etc. By a lexicographical order. So if I detect that every time there is a pairwise comparison query, students say, oh, C2 is better than C5 and C5 is better than C8. So see, this is like a primacy bias, right? Because maybe the student is saying C2 is better than C5 because she saw C2 before C5 and then she saw C5 before C8. So maybe she always prefers the project she saw earlier. And note that this is only when she gives the same grade to these projects, and then we have these comparisons questions. So I was worried about maybe in this comparison stage, students exhibit a primacy bias, or maybe in this comparison stage, they exhibit a recency bias, meaning that every time they get a comparison question, they will always prefer the last project they saw. And this means that like a student would answer, I preferred C9 over C4. So I checked both. Primacy and recency, like the descending order of projects and the ascending order of projects. And as you can see, I didn't really see anything significant here. There isn't any trend here. And I also looked at the project number. This is the project number and the percentage of voters that gave this project a certain grade. So this is very good, like how many people gave a very good to project 1, to project 2, to project 3, to project 4, because I was afraid that maybe as time goes by the time you reach the last project, you don't give a grade of very good anymore. And this is the same, but for a grade of excellent. Now note that I'm looking here at 12 projects. I only had 1 session with 12 projects. So this is logical that for 12 projects, I don't get a lot of excellent, and there's also like a little bit lower amount of very good. But in general, again, I don't see a trend here. So maybe this needs further research, but using this analysis, I felt pretty comfortable with the system, and I didn't detect a problematic bias in the data. Okay, moving on, I wanted to check the communication overload because I am asking student pairwise questions, and I know that pairwise questions, it can be pretty irritatable to answer all of these comparison questions. So I was interested in how many questions are we asking the users. And this is, again, these are the session numbers, and you can see the average and standard deviation of pairwise comparison queries that students had to answer during all of the session. A session is either 3 or 4 hours with breaks, okay? So this is a number of pairwise comparison questions they had to answer. And communication reduction, what I did is I computed what would have been the number of pairwise comparison questions they need to answer if I asked them only pairwise comparison questions without asking them to rate items at all, without asking them to give scores. And here you can see the communication reduction from, this is when you compare my method to methods that only use pairwise comparisons. Okay, so this was just like to check the data and to check the communication overload. What I was really interested was, does this method actually work? Does it reduce ties in the ranking? Now, mine is not the only method that deals with tie breaking the median. Majority voting by Valinsky and Lavaki do that as well. And Fabre recently introduced a wonderful paper that looks at a typical ranking, central ranking, usual ranking. These are all methods for tie breaking the median. This is also the name of his paper. So I compared to his methods. I also compared to the mean, because the mean is supposed to be like a sort of intuitive tie-breaking method, right? So like there's a difference between a mean of 4.8 and 4.7. So even if we get a lot of high grades, there should be a difference. And unsurprisingly, the mean didn't work so well, but also the other methods didn't work so well. Let me guide you through what you see here. So I looked at the percentage of unique rankings that I receive in the end, and I looked at the number of students. I mean, I did like, I used the data and then did a random selection without replacement of what happens if I only have 2 students, 4 students, 6 students, etc. I did it for all of the numbers, 2 students, 3 students, 4 students, 5 students, etc. All of the numbers. And what you can see is that a rating to out of B and out of C, they outperform all of the methods all of the time. They're better when there are less students, and when there are more students, other methods catch up. And you can also see that most of the time, out of B is better than out of C, and out of C, it tends to be more noisy. This is because of the tie breaking that alpha I told you about. So it depends if the number of voters is odd or even. R2RC works better when the number of voters is odd, and it doesn't have the same performance when the number of voters is even. There's 2 more sessions that I didn't put on the slide. I checked this for 6 sessions, and then I did statistical significance test that is all in the paper. And this is it's not only what you can see, this is also statistically significantly better. Okay, and the last thing I did is I also compared, in the same way that Fabre compared in his paper, I looked at the candle distance between the different methods, because here what I could see is that R2B is better than R2C and better in general. And I wanted to see, like, what is the impact of the tie breaking when maybe all of the methods perform more or less the same all of the time. And what you can see here is that, like, in 2.5% of the cases, and here is the standard deviation, so this is on average in 2.5% of the cases, we have a different ranking for R2B than for R2C. The ranking is different in one of the places. And if you look at it closely, you will see that the Auto-C is more similar to the other rankings. So if you want something that is like more consensus and more consistent, I would use R2RC because it's still better than the other methods, but it's closer. It's closer to the mean, it's closer to majority voting, it's closer to the other methods. But if I just want something that is better in general, I would use R2RB. Okay, so this is the evaluation. And what I also want to mention before we wrap up is that the Auto-Owl can be used for various scenarios. So of course, we talked about peer assessment, and we talked about Auto-Owl can overcome this over too generous rating problem, but it can also differentiate between project ratings and give us more informative preferences. So what I see is like, wow, this can be used by companies like Booking.com or other companies where I went to a hotel, I gave it a 10. I went to another hotel, I also gave it a 10. But I know which hotel I will go to again when I go to this place again. And this is something that Booking.com doesn't know about my preferences, and I do know, and if they'd ask me, I would be happy to tell them. And another thing is that this could be used as a subtle ranking elicitation technique to overcome the cognitive overload of producing a ranking. So, okay, this can be used for peer reviews, but this could also be used by management when they need to rank their employees, for example, in the end of the year when they need to decide who receives a bonus and how much bonus. So this can be like sort of a subtle way to help people or help managers rank their employees or rank anything else you need. So just to wrap up that slide, what I showed you was a rating to ranking, a peer assessment system, which can also produce, it's a subtle way of producing a personal ranking, and it has a tie-breaking preference or aggregation method. I want to thank Matan Lang for the code for the application, and Kobi Kavadi for some of the analysis. And this is still a work in progress. I have some ideas for what I want to do next, and I'll be happy to discuss this project. I can also give you the code. I can give you the data. If you really want, the system is online. I use it in each semester. I intend to keep using it even after this project ends. If you want to use the system as well, talk to me and we'll work out how to do that. I mean, I'd love it for other people to use the system as well. That's it. Thank you.